Let us learn about how to interface different motors with 8051. Let us study about stepper motor initially. Stepper motor is an electromechanical device which generates discrete displacement in response to the applied DC signals. It is different from the normal DC motor in its operation. When you apply a DC voltage to the DC motor, it rotates continuously in response to the applied DC voltage, whereas the stepper motor rotates in a certain mechanical motion itself. It gives a particular displacement for the DC voltage applied. Usually, stepper motors are used in embedded applications, consumer electronic products, robotics, control systems, and so on. We can implement the stepping action in the stepper motor by different ways. It is usually done by changing the sequence of activation of the stator windings. In this slide, it shows the construction of the stepper motor. You have the rotor in between and you have the four stator windings. Each of these stators are energized by using any of these three stepping sequence: wave step sequence, full step sequence, and half step sequence. In wave step sequence, one of the stator is being energized at a time. In full step sequence, two of the coils are or two of the stators are energized at a time. Half step sequence is a combination of wave step sequence and full step sequence. So now how do we control the stepper motor when we are interfacing it with 8051? So the stepping sequence is usually stored as a lookup table by writing its equivalent hexadecimal or hex equivalent codes. Then using the lookup table, you need to fetch the code one by one and pass it to the port through which the stepper motor is connected with a particular amount of delay. One important point to note over here is stepper motor cannot be directly connected to 8051 in case if it is having high current demands. So in that case we require a motor driver circuit and then you interface the stepper motor to it. Let us take an example. Write a program to rotate the stepper motor in clockwise direction. So first let us store the hex equivalent codes as a lookup table over here. ORGE000H. Let us move the starting address of the table to DPTR, and since I have to send every code one at a time, I will use a subroutine. So a call send. In send, in the routine, clear EA. This is the code memory. From here we are fetching. So move C a comma at a plus DPTR. In order to check where the end of the array, I have terminated it with a 0. So I am checking for 0. If it is 0, I have completed. So I have to exit out of this routine. If not, increment the DPTR to point to the next code. Send the data through port 2. We're assuming that stepper motor is connected to port 2, call a delay and then repeat the process. Once a 0 is obtained, you will return out of this particular subroutine, and again this main program will be continuously executed. And this is the small delay routine which is being written. So now if I want to rotate this in anti-clockwise direction, then I have to send the codes from 0BH, 7E and D in this particular sequence. Next is the DC motor. So it is widely used device that translates electrical pulses into mechanical movement. Usually it has two leads, the positive lead and the negative lead. Connecting them to the DC voltage moves the motor in one particular direction. If you reverse the polarity, then the DC motor will move in the opposite direction. If you would like to have a steady speed of a DC motor, then we control the DC motor with a technique called as pulse width modulation. So we are changing the width of the pulse applied to the DC motor. Amount of power supplied will be increased or decreased thereby. So the amplitude will remain fixed. The duty cycle is varied, which means higher the pulse, higher is the speed. Let us take an example. A DC motor is connected to P1.2. Write a program to control speed of the DC motor. with two different speeds depending on the condition of a switch connected to P2.4. So we have to program P2 as input port first. ORG 8000H program P2 as input port, and then we have the switch connected to P2.4. So again I have assumed here one end of the switch is connected to the port pin and the other end is connected to VCC. So when the switch is pressed, the pin P2.4 will receive a logic high. So if there is no bit over here, if the switch is not pressed, then jump to L1. In L1, I have used a different duty cycle waveform generation. So set B P1.2, I will set this, call a longer delay, clear, call a smaller delay, and S jump back to L1. So at a different speed, the motor will be rotating. But if there is a bit, then set B P1.2, caller delay, clear, and caller delay, S jump to back. So this will be executed, and this is a small delay routine and end of the program. So we find when the switch is being pressed, the with 50% duty cycle, the motor will be getting energized, or it will be activated. Here it will be duty cycle is different compared to this the initial one, and at a different speed the motor will be rotating over here. We have learnt about switches, but whenever you are having multiple inputs to be given, interfacing single switch for every input is not a feasible solution. Therefore we go for a keyboard. Keyboard is an input device for user interfacing. So if the number of keys is very limited, push button switches can be used, and they can be directly interfaced to the port pins for reading. Matrix keyboard is an optimum solution for handling large number of key requirements. It reduces the number of interface connections. So usually it is keys which are connected in the form of a row and column. So here is a diagram of 16 keys which are connected as a 4 by 4 matrix. The key press in the matrix keyboard is identified with the row column scanning technique. What do we mean by this? So if you observe the diagram, you find that the one end of the keys are connected to VCC, and the other end is connected to the microprocessor or the controller's port, and even the columns are connected to the controller's port pins. So what we do is we program these rows as output, or the port pins connected to the rows as output, and the columns which are connected to the port pins as input. The other way also can be done. So over here we make the first row 0 first. We make this particular port pin as 0. We send a 0 over here, and now we read each of the column. So each of this port pin is being checked. So say suppose if this particular key is pressed, when you make row 0 as 0, and when you scan the first column, you will not receive a 0 over here. But when you scan the second column, you will get a 0 in this particular column, since the key over here is pressed and you are bringing down the value as 0. Therefore, we conclude that this particular key is being pressed. And also, for this particular key, its equivalent value will be stored in the lookup table. So depending on the key press, you have to fetch that particular value from the lookup table and then take it accordingly as per the requirement in your application.